Python is an object-oriented programming language. Everything in Python is what? Is an object. Anything you have in Python is an object. Even your for loop is an object. Arrays is an object, which is properties and what? And methods. What are properties? Properties are the data items, or the data types, or the attributes, or the characteristics that is defined in a class. It is like the data that class needs to operate on, or to work, or it depends on how you guys can understand it. Methods are the functions in a class which the class performs a specific task on, and these methods also use these properties. It acts on these properties to perform their tasks. Okay? To perform what? Their tasks. Now, so a number, string, list, dictionary are all what? Class, are all objects with a corresponding what? Built-in class. So all the objects you guys see in Python have their built-in class that you are not seeing. If you want to see it, there's a way you can see them. Then you see all the codes and functions or methods that have been written in that class. We create a class to create an object. So that means an object cannot occur without a class. Is that understood? So classes are created to create an object. A class is an object constructor, like I said, or a blueprint for what? For creating an object. We instantiate a class to create an object. The same way you write your function. If you write a function, you call a function, isn't it? But in classes, we don't call a class, we instantiate a class. So we say that is an instance of a class. So I will say an object is an instance of a class. When you write a function, when you call a function executes its task, isn't it? Whether to return something or to execute whatever the way we used to do with functions. It may be a function to sort, isn't it? An array. It may be a function to find something in an array. It may be a function of factorial, a recursive function. All this function does something, isn't it? So when that function is called, whatever you ask it to do is done. But when you instantiate a class, nothing is done yet. Is that understood? You only created an object. So it's a different terminology, although the same process. But I will do that later in more details when I treat examples. The class defines attributes and behaviors of an object, while the object, on the other hand, represents the class. So let me treat some examples so I can now illustrate this definition and analogy in those examples. Okay, good. Now, to create a class, the keyword class. So to create a class, the keyword class is used to create a class. After writing this keyword, then you write the name you want to give to the class. Is that understood? For example, sleeping students. Then the class has been created. So this is a class has been created. Yes. We don't need the brackets. So a class has been created. Class, name of the class, full column, enter. So let me create an empty class. A class, like a classroom, no chairs, no students, nothing. An empty class. Let me write pass. So this is an empty class. This class is useless. I don't mean this classroom. I mean this class that I just created. Is what? Is useless. I have no use, no attribute, nothing. So let me print class. Sorry, not class. And what is the class? Sleeping students. Okay. Now let's run this. What is written? Class main sleeping student. It is just a class, an empty class doing nothing. So this is a class. But this is not an instance of a class. We have not interpreted what? The class. When you have an instance of a class, it becomes what? An object, isn't it? So let's have an instance of this class. So I have an instance of this class, then I write sleeping student with brackets. Then This is an object, which is an instance of the class sleeping students. Since you have that round bracket, it becomes an object. So if I print this, okay, remember the previous ones printed what? A class. If I print this, what does it print? It prints what? Object, no more class. So this class has been what? Instantiated. So this is an instance of a class. Is that understood? Now, when we instantiate a class, we always, just like you have your function, when you have a function, you will save if your function is returning a value, you save it to a variable, isn't it? Then that variable is what? Is the value that is returned. But in an object here, when we instantiate a class, we may not want to always call that class often. Then we can decide to use an object handler. What do I mean? If I write sleeping student, maybe I instantiate this class as sleeping student, for example, this is an object. If I pass some parameter, then I also write another sleeping students. How many objects is this now? 2 objects. I called one, I instantiated one class how many times? 2 class. These two things are not the same. These two objects are not the same. They won't have the same value. Even though they are of the same class, they don't have the same value. Is that understood? They are not the same thing. When you pass parameters, these two things will not have the same value, the same process. No, they are two different things. What do I mean? To make them to be the same, then you need an object handler. For example, VAR is equal to sleeping students. Now this is an object handler. So VAR is now an object handler. It is not keeping the value returned by sleeping student, because sleeping student is what? Is not a function. No value is returned. So VAR is just an object handler, like something that is handling your object for you. So if I print VAR, then that also print the same thing that you had initially. Is that understood? It's handling the object for you. So if I now have VAR1 is equal to sleeping student, I can also have VAR2 is equal to sleeping students. These are two different objects. So the value of VAR1 may not be the same as what? VAR2. For example, if I write file is equal to open names dot text, then I write maybe word is equal to file dot read. Open is an object handler for file handling, isn't it? Sorry, open is an object for file handling. Is that understood? It's an object. You pass something. What you pass is a file name, isn't it? And that is the attribute that is defined in the class. Is that understood? Now, this file you have there is an object handler. So if I print file, for example, let me print file. So that will illustrate my previous explanation. Print file. What does it print? It does not print anything reasonable for you, because it is just an object. Is that understood? But if I print word, what will word print? It prints the values in what? In that file. That is the values in names.txt. Do you understand? So instead of writing this, I can as well write that print file, or sorry, print open this dot read. here I did not use any file, only what? Any object handler, isn't it? Did I use any object handler? Any object handler? No. I only use the objects alone. If I run this, it does the same thing. Do you understand that? It does the same thing. Read and printed. That means but the problem is if I now call another object with open named .text, is doing something else different from the previous object. So to prevent that, I need to now use an object handler. So that I have file is equal to what? Is equal to open whatever. So if I want to read, I will only use that object handler to do anything on this same object. So if I want to create another object, I can save it to another variable, probably writing that maybe word, or let me say sentence, sent is equal to open, and pass another attribute. Maybe for example, string.text, string.text. So can you now see sent is another what? Another object handler. Different from what? From file. Even though you are using what? You are instantiating the same class. Do you guys understand that? This open and this what? This open are they not from the same class? They are from the same class. Do you understand? But this handler is different from this handler, even though they are instantiating what? The same class. Is that understood? So, according to this example, var1 and var2 are different what? Are different objects, isn't it? But from the what? From the same class. Now, like I told you, that this class has no use, no function, and very useless. How do we now make it have a use? How do we make it have a function? So let's move to that. Class constructor. In the previous examples, we have created an object from the sleeping students class. However, a class without a constructor is not really useful in real life application. Is that class useful? No. The constructor in Python is a built-in constructor. It is called the init construction. It's called what? Init constructor. Okay. These are self-parameter, which is a reference to the current instance. So let me go back to that example to explain what a constructor is and how to use it to make your class meaningful. So like I told you, this class is useless. If you want it to be useful, you need a constructor. And for Python, we have the built-in init constructor. So how do you do that? Then you write def is a function. Okay, that constructor is a function. Because it's until you have function that your class now acting on something. It now has a function. Okay, good. So we have def. How to write your init? Double underscore init double underscore. So this is the init function. In this init constructor, this is where you now define your parameters. Or sorry, define the attributes that will be passed. This is here where the attributes are what? Are defined. If you recall in the past examples we have done, when you have dot something like dot strip, it may require no attribute or attribute. Do you know you may pass something or not, right? Whether you pass something or not depends on what you define, or what was defined in the init constructor, or what was defined in the class, or what was defined in the method in the class. So here, the attributes required by this class are defined in this constructor. But the first thing you have to write, whether there is attribute or not, is self. This is a keyword, self. But it's not an attribute. Let's assume I want to pass 3 attributes. Okay, then comma, name, address, number. So here I have defined that I want to pass 3 attributes in this constructor or in this class. Is that understood? So if this object is instantiated and you do not pass 3 attributes, then there's an error. This is like setting a rule. This is not 4. These are how many? 3. This self is a keyword. I will tell you what it means now. Now, how do you now define it in this class? Then you now have self dot the attribute name. Let's say name is equal to name. These 3 parameters I wrote here, they are like variables that will take the attribute you want to pass in. So I may call this, let's say X. Then I may call this, for example, Y, and I may call this Z. Although it's not a good practice to use ABC. Then self.name is equal to X. Yeah. This X here is the variable you have set here in the init constructor. Why this self.name is defining the attribute to the class. That in this class, we need an attribute name in this class. It has been defined as the variable X that will be passed. That means if you pass the variable X, it is defined as name. If you pass the variable Y, it is defined as address. Dot address is equal to Y. And self dot number is equal to Z rather. Okay. So this is saying that 3 parameters is required by this what? By this constructor. And they are defined to what? As the attributes of this class. So self is that keyword that defines the attributes. Do you understand? Like it makes those parameters to belong to it. That's what it means. Is that understood? So saying self.name, actually there are 3 attributes. What are the 3 attributes? Name, address, and number. These are the 3 attributes in the class. So in defining them, we now define them as what was passed to the constructor. But most of the time, to avoid confusion, I always advise students to use the name of the variables as the name of the attributes. I always advise students to use the same variable name and the attributes. Okay? Just to avoid some confusion. So instead of writing XYZ, then I write self, name, address, number. Then self.name is name, self.address is address, self.number is what? Number. So how many attributes have been defined in this class? 3. Is that understood? So when you now instantiate the object, how many parameters are you required to pass? 3. Then the first parameter will be the what? The name. Okay? So whether I write name, address, and number here, it doesn't matter. What matters is this name, address, and number. These are the real attributes, the one with self. Is that understood? So I want to make them the same name to avoid confusion while writing our code. Is this understood? Okay, good. Now, another thing you have to note is that these attributes have been made public and not private. I'll come to that later. Now, this class now has something. It's no longer empty, isn't it? So let's now look at the use of this class. Does this class have methods? No. It only has attributes. Is that understood? An attribute determines the properties of what? Of the object. So let's now use this in an example. Very simple example now.